Welcome to qnawire.
So in this problem, we're supposed to calculate the voltage across the tube given the shortest wavelength bremstrahlung X-ray emitted from an X-ray tube that has a wavelength of 0.007 nanometers. So it basically means that uh, here on the y-axis we have, X-ray intensity, and here we have wavelength, and at some point the continuous part of the curve starts, and this is the value lambda 0 which is given to us in the problem, and we are asked to calculate the voltage across the tube. Now, in order to calculate the voltage across the tube, we use equation 39.10 from the book, which basically tells us that the shortest wavelength is equal to Hc over EV, where V is the voltage across the tube. So basically this means that this wavelength corresponds to the wavelength of the emitted photon when an electron loses all of its kinetic energy to the collision. So V is just Hc over E lambda 0, and then we plug in the values 6.63 times 10 to the power minus 34 joules second, 3.00 times 10 to the power 8 meters per second over 1.60 times 10 to the power minus 19 coulombs. That's right. C times 0.027 times 10 to the power minus 9 meters. So basically this gives us the value for V. Go to the next slide. V as 46 kilovolt, which is basically 46,000 volt. So this is the amount of voltage that needs to be applied across the tube in order to get the cutoff wavelength of 0.027 nanometers.